Distinguished viewers all over the world, welcome once again to Simplified Maths class. I am your host, Mr. Mike Omeni, and today we are introducing the topic bearing and distances. But before we proceed, please, if you have not subscribed to our channel, Simplified Maths class, kindly do that by hitting the red subscribe button, and God bless you as you do that. Alright, without waste of time, we are taking bearing and distances and understand that this is a topic we have been waiting for. Why? Because of this topic, we have dealt extensively with the sine and the cosine rule. And we had also learned the use of SOHCAHTOA and Pythagoras theorem. All this concept prepares us for bearing and distances. Now, what is bearing? Bearing is simply the angular distance between 2 points mapped on space. It means that if you want to travel from one point to the other, you need to know how far apart these 2 places are. That's the distance. And then we also need to know how far the other place from the other place via the angular distance. So via what we call the bearings. The bearing tells us the distance between the 2 places in an angular form. And this angle is usually measured from the northern pole to the point where the other town is, clockwise. So we measure it clockwise from the northern hemisphere. Alright, so if we want to check what the distance is, please watch. Assuming you have 2 points A and B. Now, this is point B and this is point A. You can only know the bearing of B from A by simply bringing the northern pole, is this. And then if you draw a straight line from here to this place. From A to B, here we have the distance. How far A and B are apart. But you need to know the location of B by the use of the angle. Alright, so measure it this way, clockwise, from the northern pole, from the northern pole to B. So you will be able to know by this angle what B exactly is. Because B would have simply been here. B would have also been here. B could also be here. But it's the angle that pinpoints the exact location. Because this angle here we have measured can be 110 degrees. So with 110, we know that B is towards this side. But however, if it is more than, let's say we have about 170, with 170 degree, we would have known that B is here. Alright, so let's say 200 and something degrees, we would have known that the place is here. And with 300 and something degrees, we would have known that B is this other side. So you can see that you can only know the location of B from A by the angular location, which we call the bearings. So it pinpoints the exact location. Take note of that. Alright, so in bearings, there are 2 ways we measure bearings, or 2 ways bearings are presented. The first way is by the use of the 3 digits. By the use of 3 digits. Now, we can do that by the use of 3 digits. The bearings are represented as 3 digits. The 3 digits could be, let's say, 0.25 degrees. That's 3 digits. Let's say 0.60 degrees. That's 3 digits. Alright, so we can have 100 degrees. That's also 3 digits. 100 degrees. That's 3 digits. We can have 146 degrees. We can have 220 degrees. We can have 310 degrees, etc. So every angle by the use of the 3 digits is represented using 3 digits. So that's the first way of presenting our bearings, the angular distance, by the use of 3 digits. And the second way is by the use of any 2 of the 4 cardinal points. Here, we represent the bearing by the use of any 2 of the 4 cardinal points, meaning that we can have north 20 degrees east, we can have north 35 degrees west, we can have south 16 degrees east, and we can have south 49 degrees west. So by the use of any two of the four cardinal points, so you see that the angle given is usually in the center, and then we must make use of the two cardinal points, the major one being north or south, and then the angle at the end you now have east or west. So by the use of any two of the four cardinal points, but we'll always start from either north or south, and that's why you can have north 20 degrees east, north 35 degrees west, or south 16 degrees east, or south 49 degrees west, as the case may be. So when bearing is presented in this format, we have the second aspect of the bearing, which is by the use of any two of the four cardinal points. Alright, so today we'll be treating by the use of the three digits. When we meet in our next slides, we'll concentrate on solving problems by any two of the four cardinal points. Okay, so how do we handle by the use of the three digits? Let's take some examples. Now, before you proceed on these bearings, understand that if you have not attended the class or you have not seen our videos on sine and cosine rule, please go back to sine and cosine rule, understand it perfectly well before you return to this video, to this slide for the bearing and distances. Because without sine and the cosine rule, in most cases, you won't be able to solve bearing problems. And in very rare cases, you need the SOHCAHTOA or the use of the Pythagoras theorem to solve bearing problems, but it's in rare cases. Alright, so see how we can solve problems that involve bearing and distances, mostly using the sine and the cosine. Now, there's a question about here. We have that a boat sails 6 kilometers from a point A on a bearing of O 65 degrees to point B. Please don't forget, when we are representing out problems in bearings, the angular distances are more important to pinpoint the location of the places. And we do that by measuring from the northern pole to the point we are looking for. And the angular distance is measured clockwise from the northern pole. Clockwise, which means this is the northern pole. So you must start this way and move clockwise to wherever you want to stop. So that you can now take that angle. You can be able to know the distance between point A to point B, as the case may be. So we must always move clockwise from the northern pole. That's one thing you have to understand. It is never anti-clockwise. You move it clockwise. Alright, so we have that a boat sails from a point A on a bearing of 065 degrees from a point A. Alright, so let's say this is point A. So this is point A. We want to move on a bearing of 0.65. Of course, from here to here is 90. If you have a line this way, it will be greater than 90 but less than 180. If you're moving this way, it is greater than 180 but less than 270. And if you're moving this way, it is greater than 270 but less than 360. So this is the first quadrant that contains angle from 0 to 90. This is the second quadrant. In second quadrant here, we have 91 to 180. In the third quadrant, we have 181 to 270. And in the fourth quadrant, we have 271 to 360. So when you have a bearing of 0.65 degrees, it tells you that we are dealing with the first quadrant. So they say the boat sails 6 kilometers from a point A on a bearing of 0.65 degrees to point B. So 65 can be here. That's a straight line. It must be straight. So you have to have a straight line. Alright, so that's 0.65. We've been able to map out 0.65 degrees to a point B. So we have this point to be point B. So here is the northern hemisphere. This is the north. You can indicate the north or you leave it that way. But the arrow tells you that that's the north. Please don't forget. So we have the point B here. So the distance from A to B itself, they said a boat sails 6 kilometers. 6 kilometers from a point A on a bearing of 0.65 to point B. That means from A to B here, the bearing is 0.65, but the distance is 6 kilometers. So you have 6 kilometers here. Alright, so let's see. They now say, and then the boat moves 13 kilometers from B on a bearing of 130 136 degrees. 136 degrees. All right, so 136 degree rather should go down this way. 136 has to go down. So let's see how we can shorten this so that we'll have small space. All right, so this 6 kilometers. So this is where B is, our town B. So this is A town B, 6 kilometers. We've gotten the whole 65. So from there we need to move 13 kilometers on the bearing of 136 from B. So from B we want to move T on a bearing of 136 degrees. On a bearing of 136 degrees. 136 we are moving again from B. That to 136. 136 to get to 180. Stop anywhere here and draw a line that way. So that's how we are moving. But we are going on a distance of what? 13 kilometers. So 13 will be longer than 6. So we can now have, so it means this is where C is. This is the northern pole. Please take note of that. So from here to this point, we have 136. 136 degrees. That's the bearing of C. From where? From B. So from B, we are running 136 degrees this way. So that's where C is. But understand that here is 6 kilometers, but this other side is 13 kilometers. So we try to make this side longer than the 6 kilometers. So from here, we can now join the points to form a triangle. So we have joined to form a triangle. This is straight, please. It should be straight. So that's a triangle. I'm not using a ruler, so you have to, normally you should use a ruler so that you have very straight lines. But I don't have a ruler here, so I'm trying as much as possible to make it very straight. Alright, so let's take that as a straight line. Let's manage that. So this is a point A, this is point C, and this is point B. Now, before we can solve anything, we need to first define the angles that are inside. We have gotten 6 kilometers here, 13 kilometers. Remember that from B to C, we have 136 degrees. That's 136. But from A to B, that's the bearing of B from A is 0.65, which is this. But from the bearing of C from B is 136 degrees, which is this. And I'm giving us here B to be 6 kilometers. And then B 13 kilometers. Now, what did they say we should find? Say, what is the distance and the bearing of the boat from point A? Which means the boat is now here because the boat was here. And then it moved to B. From B, it moved to C. So this is the final point of the boat. So we want to know the distance from A to where the boat is. From the starting point to where the boat is. So AC is what we need. So we need AC. Line AC. That's the first thing they want us to calculate. And then the next thing they say, what is the bearing of the boat from A? That's the bearing of the boat C from A, because the boat now is at C. So we need the bearing of C from A. How do we do that? The bearing of C from A, meaning we should move from here and touch C. That's the bearing we need. Remember the other one was here, but the one we need now is from here to this point. So we need the bearing from here to this point. That's the bearing. And for us to get this bearing that we are looking for here, it means we must calculate this point, theta, and then add to 65 degrees. We need to find the angle here in the triangle, which is theta. So whatever theta is, which is from here to here, by the time we add 0.65, it will give us the bearing of C from A, which is what we are looking for. So that bearing will be 0.65 plus theta, because it is from here to this point. But we've already known from here to this point to be 65 degrees. Please take note of that. But the major thing here now is for us to find the distance from A to C. And that distance from A to C is small b. That distance is small b. We call it small b. Why is it small b? Because it is small b that faces the big B. Alright? Now, let us define the parameters given. From here, small a is given. Small a is the side facing the big A, which is 13 kilometers. And we have also gotten small c. Small c is the side that is facing the big C, which is this side, and it is given as 6 kilometers. We have known small a and small c, but we are looking for small b. Small b is what we are looking for, which is the distance from A to C. Aside from that, we need an angle inside. Let's see if there is any angle inside. Let's see. Now watch. If from here to here was given as 65 degrees, that bearing, 065. Understand also that by alternate angle, if from here to here is 65, also from here to here is 065. Take note of that. So we have 65. By alternate angle, the angle from here to here, which we said was 65, is alternate to this. Understand that this is a straight line here. So you have a straight line here, and then you have a straight line here. The angle you have here by alternate angle is equal to this angle here. That's what we just did. So the angle here is 65. It is alternate to this place, which is 65. So we have already known that in there is 65. That's the first thing. So we know by alternate angle this is 65. Now, but how do we know this place here? Because we need also here for us to be able to define the angle that is inside there. Now, how do you know this place? Know that from here to here was given as 136. However, from that point to this line is 180, angle on a straight line. So from this point to touch here will give us 180. But we have already known from here to here as 136. So what will be here? That will be 180 minus 136. So 180 minus 136 will simply give us 44 degrees. Alright? 180 minus 136. 180 minus 136 will give us 44. So here is 44. So here is 044. It therefore means that if you sum 65 and 44, that will give you the whole angle we have here. 65 and 44, 44 or 65 simply give us 109. It means we have 109 degrees in 3 digits. It's simple. You know that this is 65 by other angle here is 65 too. And you also know that from here to here is 136. But from here to this point is 180. So 180 minus 136 was the next angle here, which is 44. So 65 plus 44 was 109. And if you look at the problem, in bearing and analysis, the first thing you have to know is to identify one of the angles in the problem. Because two sides are now, that one angle can either solve by sine rule or by cosine rule. Here, we have side, and incident angle. And from our previous slides in cosine rule, we have told you that anytime you have side, and incident angle, you have to use the cosine rule. So we know the angle at B now. The angle at B is 109 degrees. So we'll be able to know that it's 109 degrees. So the use of cosine rule, we can be able to calculate small b using sine rule. And understand that by cosine rule, b squared is equal to a squared plus c squared minus 2ac, the cos angle of b. Alright, so our b squared will be equals to, what's the a? A is 13, so we have 13 squared plus c. C is 6 squared minus 2 times 13 times 6. And then the cos angle, the angle at b, we have defined as 109 degrees. So we can apply the cosine rule very simply. So here we are going to have b squared is equals to 13 squared is 169 plus 6 squared is 36 minus 2 times 13 times 6. 2 times 13 times 6 will simply give us 156, and then the cos angle of 109, cos 109 will give us minus 0.3256. So this is what we are going to have. So the cos angle of 109 degrees will give us a negative 0.3256. Alright, so here we are going to have b squared will be equals to 169 plus 36. 169 plus 36 and that gives us 205. Here we are going to have 205. Now this minus and this minus becomes plus. Please take note of that. Alright, so 156 times this. So we have 156 times 0.3256. So we are simply going to have 50.7936. So that's what we have. So if you multiply this by this, you have a positive this. So our b squared will be to add this answer to 205. So we add that to 205. We are simply going to have 255.79. 255.796. Our b alone will now be the square root of 255.7936. That will simply give us a b. So square root of that, square root of that answer will give us 15.994. That's the b. But they said all answers must be. Did they give us any approximation? No approximation. Therefore, we've been able to calculate the distance from A to C, or the distance of the boat. The distance of the boat from A will simply be, to the nearest whole number, 16 kilometers. So we are approximating to the nearest whole number, that will be 16 kilometers. So we've been able to find the distance from A to C, which is 16 kilometers, and that is expected. Why? Because what we have here is the largest angle of the triangle, which is 1. So since here is 16 kilometers, here is 16, we expect this side to be longer. Why? Because it's facing the biggest angle. It's that simple. So we've been able to calculate the distance of the boat from A, because this is where the boat is now, and this is from A. So we've been able to calculate the distance AC, which is small b. That's all. Now the next part is the same. We should find the bearing of the boat from A. The bearing of the boat, that's the bearing of C from A, which we have already told you is from here to here. So we simply need to get theta. After getting theta, we add 65. We have gotten the necessary bearing. So that takes us to the second part. Now don't forget, we have calculated this part now. We have calculated that part. So our B now is 16 kilometers. 16 kilometers. We've been able to calculate that. So let's see how we can get the bearing, which is the I part of the question. Let's see. Let's simply bring it out. Let's see how we can get the I part of the question. Now, in the I, or the second part of the question, they say we should get the bearing of the boat. Where is the boat now? The boat is at point C. Now, from the starting point, which is from A. And that bearing will simply be theta, which we are going to calculate, and then we add it to 65 degrees. So the moment we take the theta and add 0.65 degrees, we'll be able to define what we are looking for. The bearing we are looking for. We express all in degrees. Now let's see how we can do that. Now we have here 109 degrees facing 16 kilometers. Then we have 13 kilometers facing the angle we are looking for, theta. Of course, we can define that in terms of sine rule. Let's see how we can do that. Now we have known angle A. The angle A is equals to theta, which is what we are looking for. But small a, which is facing that A, is 13 kilometers this side. Small a is facing A, which is 13 kilometers. So small a is 13 kilometers. Also, we have known the angle at B. The angle at B is 109 degrees. 109 degrees, yes. And then we have already calculated the side facing the B, which is small b. And our small b now is 16 kilometers. So with this, we can be able to deduce the value of theta using sine rule. Alright? Because if you look at it, where you small a, big A, small b, big B, small a, big A, small b, big B. So we can know the theta by the use of sine rule. So by sine rule, we know A all over sine A is equals to B all over sine B. It's that simple. We have done this in the previous slide. So what is our small a? 13. So we have 13 all over the sine angle of A. Sine angle of A, which is theta, what we are looking for, is equals to B, 16 all over the sine angle of B, 109 degrees. So we can simply know what sine theta will be. So we cross multiply. 16 times this will give us 16. The sine angle of theta is equals to 13 times this will give us 13. The sine angle of 109 degrees. So our sine theta alone will give us 13, the sine angle of 109 degrees divided by the 16 that is. So we can able to know, we will be able to know what sine theta is. So how do we conclude that? So we are going to have the sine angle of theta to be equals to 13 multiplied by what is sine 109. Sine 109, the sine angle of 109 degrees will give us 0.9455. 0.9455 all over, what do you have here? 16. So our sine angle of theta will be equals to 13 times that. 13 times 0.9455. Now we now divide that by 16. So we'll simply have 0.7682. 0.7682. Our theta now will be the sine crosses to be the arc sine of 0.7682. That is the cosecant of 0.7682, which means we are looking for the shift time or the function of sine. So the second function of sine of 0.7682 will simply give us the answer 50.2 degrees. So our theta equals to 50.2 degrees. We have got theta. Now the required bearing we are now looking for, the bearing of C from A. The bearing of C from A. You can now conclude, therefore, the bearing of C from A, which we said is theta plus 65, will be equals to theta now is 50.2 plus 65, and that will give us that bearing. 50.2 plus 65 will give us 115.2 degrees. So the angular distance we are looking for is 115.2 degrees. It therefore means that the bearing of C from the point A, which is theta plus 65 degrees, will give us from here to here, which is 115.2 degrees. So if we are looking for from here to here, from this point to this point, will give us 115.2 degrees, which is the bearing of C from point A. Please take note of that. If we look at the bearing we have just done now, we have been able to apply both the sine rule and the cosine rule in solving this problem, and we've been able to have our answer accurately. So it's that simple. All right, so we are going to take another example on how to apply or how to solve problems that involves bearing and distances using sine and cosine rule and by the use of the 3 digits. So let's see how we can try a second example, a second one. That takes us to number 2. Now in our number 2 problem, we were told that the bearing of A from B is 310 degrees, and the bearing of B from C is another degree. So we should find whatever comes after that. So let's see how we can do that. So we have a problem on the board here. The bearing of A from B. The bearing of A from B is, the bearing of A from B is 310 degrees, 310 degrees. We've been given that. And then secondly, here they said, and the bearing of B from C is 230. And the bearing of B from C is 230 degrees. We've been given 2 bearings. They now say if from A to B, what you have is 28 kilometers. And then the distance from BC, they say BC is 43 kilometers. Now they say we should simply calculate, correct to 3 significant figures. Calculate the I part, the distance AC. Calculate the distance AC. We should calculate the distance AC to 3 significant figures. And also the bearing of C from A. The bearing of C from A. Alright, so let's see how we can solve this. But the first thing we need to do again is to bring out the problem. To design the problem. To bring out this on a map. Now the bearing of A from B is 310. The bearing of A from which point? From point B. From point B is 310. Wow. So this is point B. Let's say this is point B. And they say the bearing, this is point B. Let's have B anywhere here. Let's say here. So the bearing of A from B is 310. So how do we get 310? How do we get 310? 310, we start from here and move clockwise-ly. 90, 180, 270, 310 should be here. So we take that straight. We take it as a straight line. So we have that. So this is where we are stopping. So this is 310 degrees. To a point where, to a point A, the bearing of A from B is 310. So we are getting to A. This is where A is. So this is the point where we have A. That's the northern pole. So that's 310 degrees. Please don't forget that. Now, this is point A. Now, they now said, and the bearing of B from C. So, from C, if you want to get to B, you have to move on 230. Wow. That means likely that B will be here. Somewhere here. Because 230 will take us to this direction. Our 230 will swing us to this direction. So, it means B will be here. Somewhere here. So, let's bring out 230 degrees from the point C, because they say the bearing of B from where? From C. So the point C is here, somewhere here. So this is the North Pole. Now this is the point C. We want to move 230 degrees. So 230 is to move from here, 180, 230 somewhere here. 180, 230 is somewhere here. Alright, so we take a line from there straight. So that's what we have. Please take note of that. So we take a line from that. So this is the bearing of B. From which point? From point C is 230. So if you go around here, what you have is what we call 230 degrees. Please take note of that. Now, we need to join those two places now to form a triangle. So we join here. So that's what we have. So we have gotten a triangle with A and C and B. What we need is an angle inside. How do we define the angle? But don't forget, they say the bearing of A from B. So from B here, to define A, we have to move 310. 310 is this way, clockwise-ly to where you have 310, which is above 270. It takes you to the 4th quadrant. So when you draw that line, it takes you to the point A. And now they now said, and the bearing of B from C. From where? From C. Where is B? It has to be 230. 230 will definitely cross 180 and come in here. So that's 230. Don't forget that. It's touching that line. That's 230. So when you get to where you have the 230, you draw a line to meet the point B. Because they say the bearing of B from point C is 230. So 230 will define where B is. So you've been able to know the locations A, C, and B. Now we need the angles inside. How do we get them? First, we need this angle. And then after that, we need this other angle to form the angles. But they are simple to define. Very simple. Now, watch and see why they are simple. By alternate angle, whatever is here will give you what is here by alternate angle. whatever is here, hidden here, will give you what is here, inside. That's alternate angle. That's how you define that angle. Okay, now how do we know this angle here? Okay, you have 230. If you take away 180, which is angle on a straight line, you will get what is here. So the angle that is here will be 230 minus 180 degrees. So 230 minus 180, I think that should be 50 degrees. 230 minus 180 will give us 50 degrees. So 50. It therefore means that what is here, from here to here alone, is 50 degrees. 0, 50. And that 50 degrees by alternate angle will give you what is inside here. So what is inside here will give you that 0, 50. So you've been able to know that here is 50 degrees. Because if you have 230 here, minus angle on a straight line 180, to give you here to be 50. Take note of that. And if here is 50, here will be 50 by alternate angle. The same thing applies. Let's see what this other angle will be. This other angle we are looking for, that will be here now, inside here, will be, alright, so we turn all round here to this place and it gave us 310. But there is an angle we are looking for here. That angle will be 360 degrees minus the 310 we have gone round, minus 310. 360 minus 310 will give us another 50 degrees. So it means here also will be 50 degrees. Please take note of that, 50 degrees. Because when we turn from the northern pole to this point, we had 310. So what is missing to complete circle? Missing angle is 360 minus 310, which is 50 degrees. So it means that we have been able to know the angle that is now here as a whole. 50 and 50, that's 100 degrees. So we have known that to be 100 degrees. It's that simple. Now already they have given us line AB to be 28 kilometers. From AB, they said it's 28 kilometers. And they have given us BC, 43. From B to C, they said it's 43 kilometers. Alright? If you have a space, you can actually make this longer. 43 would have been longer, but it's still okay. Alright? Since we are dealing with the figures, our answer will still be the same. But 43 naturally should have been longer. So C would have been somewhere here, joining this. But it's still okay, your answer. It won't affect your answer. I don't have space, that's why I couldn't take it up very well. Alright, now with this, we can be able to find the first thing they said, calculate the distance AC. So the distance AC will be here, which is the small b. So we need to calculate the small b, which is the distance AC. We need to calculate the small b, which is here. Now, to calculate the small b, when two sides and an included angle is given, also use the cosine rule. You see why cosine rule, sine rule, they are very important in bearing and distances. So for us to have been in this side and this side to with this included angle, so what we have is side and included angle SAS, and we'll still use the cosine rule. And by cosine rule, we are looking for small b. Small b, which is b squared, of course, will be equals to a squared plus c squared minus 2ac, the cos angle of the angle at b. Please take note of that. Now, what is our a? Our small a is the side facing the big A. So our small a now is equals to the side facing A, 43 kilometers. And our small c is the side that is facing the big C, which is this side, which is 28 kilometers. And we have known the angle at B. The whole angle at B is what we calculated as 100 degrees. So with this information, you can solve by the use of cosine rule. So our b squared will be equals to, what is A? A is 43, so that will be 43 squared plus C. What is our C? 28. 28 squared minus 2 times 843 times C, 28. And then the cos angle of B, which is 100 degrees. Alright, so we can be able to get our b squared now to be equals to 43 squared. So we have 43 squared, which is 849, plus 28 squared, 784, minus 2 times 48, 2 times 43 times 78. This was 2408. And then the cos angle of 100, that will be negative, cos 100, 0.1736. Negative, a negative 0 point that. Alright, so we've been able to get that. So we can now say b squared will be equals to, we add this to this. So we have 1849 plus 784. And that will give us 2633. This minus will become plus. So 2408 times this. 2408 times 0.1736 will give us 418. 418.0, let's say approximately 3. Now we are going to have our b squared to be equal to, add this to this. So we have 263 plus 418.03. We say we have 3051. 3051.03. We can say b now is the square root of that 3051.03. So our b will be equals to, we'll look for the square root of that. So the square root of that will give us 55.24. 55.24 kilometers. And they said correct to 3 significant figures. So our b now will be equals to the first, the second, the third significant figure. Now 55.2 kilometers to 3 significant figures. So this is what we have as the distance. Therefore, the distance AC, will simply give us 55.2 kilometers. That's our answer. So we've been able to calculate the distance from A to C by the use of cosine rule. Why cosine rule? Because we have side, and included angles. We solve by cosine rule. Now the second part of the question says we should calculate the bearing of C from A. The bearing of C from A, which is from here to here. The bearing of C from A. Now the bearing of C from A, how do we know that? The only way we can do that, which I want you to try that and drop your answers in the comment section, I will mark it. Alright, so we need to first get here, which is theta. Because we need the distance, the bearing of C from A. From A, the bearing of C. So the only thing to do is to find theta here. Please take note. And you have known that if here is 50 degrees, by alternate angle, here also is 50 degrees. If here is 50 degrees, by alternate angle, here is 50 degrees. Now, here is theta. So, by sine rule, you are going to calculate here theta. When you get theta, remember that from here to here is 180. So, that bearing, the bearing of C from A, the bearing of C from A will simply be, the whole of here to here is 180. So 180 minus theta and 50 and 50. So that will give you the bearing you're looking for. Because from here to here is 180. If this is 50, this is 50 by alternate angle. We can calculate theta here by using sine rule. This place, this place, this place, this place. So you can calculate theta by using sine rule. So by the time you take 180, you subtract 50 degrees, you now subtract theta, you'll be able to know what is left with, which is the bearing of C from A. So the bearing of C from A will simply be 180 degrees minus theta plus 50, because this is theta, this is 50. So if you sum what you find as theta, you sum it to 50 and then subtract from 180, you will get the bearing you're looking for. So as soon as you get that bearing, please don't forget to drop on the comment section. I'll tell you whether you're right or you're wrong. It's simple. But how do you first need to do theta? By the use of sine rule. Because you have this side giving this angle, and this side you have calculated. So you can be able to get theta the use of sine rule. Please, thank you very much for attending our class, hearing and distances. We are not going to end here. We are going to meet next in slide 2 or part 2 of our bearing and distances to still solve another example on bearings using the 3 digits before we introduce using any 2 of the 4 cardinal points and then solve using any 2 of the 4 cardinal points, and then we'll know that yes, we have arrived in bearing and distances. Please, if you enjoyed our class on bearing and distances, give us a thumbnail. If you have any question, please drop it on the comment section. But don't forget to also get the bearing of C from A, which is 180 minus theta plus 50, and drop your answer in the comment section, and I'll tell you whether you're right or wrong. And please, if you have not subscribed to our channel Simplified Maths Class, kindly do that by hitting the red subscribe. But ignore if you know you have already subscribed and you're one of my subscribers. God bless you as you do that. Until we meet next in Bearing and Distances Part 2, I still remain your host, Mr. Mike Omini. Have a wonderful time. Cheers.